In the given circuit, find the power consumed by the circuit. Find the power consumed by the circuit. Total circuit adigaru. Can anyone try it? First, we need to find the effective resistance beta. First, we need to find the effective resistance. Now, see, this is positive terminal, this is negative terminal right now. అంటే ఇది మొత్తం పాజిటివ్ టెర్మినలే కదా, అవునా కదా? దిస్ వన్ ఇస్ కంప్లీట్లీ పాజిటివ్ టెర్మినల్, దిస్ వన్ ఈస్ కంప్లీట్లీ నెగటివ్ టెర్మినల్. Agreed? That means if this point of the wire, either it is connected here or either it is connected anyway, they are connected to the same potential, and this point of the wires are also connected to the same potentials. Do you agree?
Yes, sir.
That means, so when there is a flow of a current right now from this one, say for example some I amperes, the moment it reaches the junction, it gets divides right now here, it gets divides here right now, it gets divides here right now. So everywhere there is a division of current, everywhere there is a division of your current part of relation, isn't it? See, whatever is current, this 2 and this 2 will be in which combination? Can anyone tell me better? This 2 and 2 ohm will be in which combination? Series combination. Avuna? 2 and 2 will be in which combination? Series combination. 4. If 4 and 4 ohm in the middle is also in which combination? Series combination. So that will be equal to how much for me? 8. So can I draw the circuit something like this? I'm keeping the upper circuit as it is. Okay. And lower part also there is one circuit like this. I'm keeping like this one also. Okay. Now, ఈ 4 ohm and 4 ohm ని నేను ఇక్కడ కనెక్ట్ చేసుకుంటున్నాను. So can I connect here because they are connected to same condition? So this one is like this one is like this. The another one is also like this because it has been passing upon that one. This is 4, this is 4, this is 2, this is 2. Above one is 4, above this one is this one. And this is connected to the battery like this. This is a positive terminal and negative terminal with internal resistance associated with this one. So this is having an EMF of your how much? 2.2 ohm volts, and internal resistance is equals to 1 ohm. Now, this 2 and 2 will be in which combination better? Can you tell me? This 4 and 4 will be in series. This 2 and 2 will be also in series. That means effective resistance will become how much better for me? If I'm drawing the circuit right now, this will become for me, above circuit will be equal to same as that of your previous one. And down circuit I'm writing as it is. That one is nothing but equal to your how much? Same, 8 ohms. This one is your 4 ohms. So 4 plus 4, that will become for me your 8 ohms. 2 plus 2, that will become for me how much? 4 ohms. This total is been connected to an external source of battery, positive terminal, negative terminal, and internal resistance somewhat like this. Okay, now this is 2.2 and this one is 1 ohm. Now tell me what all these combinations are right now. The మొత్తం ఏ combination అవుతుందన్న? All of them are in which combination? Parallel combination, isn't it? So can you tell me what will be the effective resistance for this one beta?
7/3. Oh, no, sir. 4/3.
So this will be equal to one resistance, isn't it? And here this is your battery, positive, negative, and there is one internal resistance. And then Anna?
4/3.
4/3 ohms. This one is how much? 2.2 volts. Internal resistance is 1 ohm. So now can I calculate the current from this one? Isn't it? Now these two are in which combination? 4/3 and 1 ohm are in which combination?
Series.
Series. That means 4/3 plus 1 will be equal to how much?
7/3.
7/3. That means this will be an effective resistance right now. This is connected to the battery, positive and negative. So this is 4/3 plus 1. This will become for me 7/3 ohms. Clear? This one is 2.2 volts. Isn't it? Is it clear? Now what is asking? Power formula. What is the power formula beta in terms of resistance? P is equals to V square divided by R. Isn't it? V value is how much for me? 2.2. And then this one is here how much? 2.2 whole square divided by resistance. Resistance is how much? 7/3. See how much I'm getting. So this one is 2.2 into 2.2 into 3 divided by your 7. See how much I'm getting this one?
So 2.07.
2.07. Sure. 2.07 unit watt. Okay na? Question is in the leda.
Yes, sir.
This one was asked in the recent your JEE mains question beta. August lo. On August lo exam jarigindi kada mains fourth phase. చూసారా పేపర్ దాంట్లో అడిగిన క్వశ్చన్ సి హౌ సింపుల్ ఇస్ ఇట్ ఇస్ అంటే మొత్తం కరెంట్ ఎలక్ట్రిసిటీ తీసుకున్న తర్వాత మీకు అడిగింది ఏంది హౌ టు క్యాలిక్యులేట్ ద ఎఫెక్టివ్ రెసిస్టెన్స్ అండ్ హౌ టు క్యాలిక్యులేట్ ద పవర్ సింప్లీ వన్ లైన్ ప్రాబ్లం అవునా కదా చేయగలుగుతారా
Yes, sir.
చూడు సి దిస్ క్వశ్చన్ బెటర్ an observer and a source an observer and source both are moving away with velocity 20 meter per second each in opposite direction if frequency of sound observed is 1800 hertz, then what is the actual frequency? Velocity of sound is equals to 340 meter per second. Can anyone tell me the answer for this one better? I'm giving the options 1906, second one is 1903, third one is 1912, and fourth one is 1947. These questions are for both of them better because they're simple questions which can be even asked for your NEET examination as it is. Even this is simple questions which can be asked for the NEET examination. That is the reason I'm discussing them here. So what is the general formula for the Doppler effect? You're going to gurtunda. N dash is equals to your N into your V minus of V naught divided by V minus of Vs. Gurtunda. Doppler effect formula. N dash is equals to your N into V minus V naught divided by V minus of your Vs. What is V? V is known as velocity of sound. V naught is velocity of observer. Vs is the velocity of source. What is given in the problem? An observer and a source are moving away. That means what? This fellow is moving in this direction. And this fellow is moving away. This is observer and this is source. Both of them are moving in away opposite direction, isn't it? So what is happening is this who is producing the sound beta? Frequency of the sound observed by the if the frequency of sound observed is 1800 hertz, then what is the actual frequency? Now this observer will hear the frequency like this, isn't it? Sound is in this direction, observer is also in the front direction. So this is a given condition. Source is moving away, gada. Direction of the sound will be in this direction. Observer is in opposite direction. So what I can take here? Sign convention will be equal to N dash will be equal to your N into your V minus velocity of sound, velocity of observer. Both of them are in the same direction. So this will be your positive divided by velocity of your source and velocity of sound. Both of them are in the same direction. Right now for this one, velocity of sound will be heard in the opposite direction, because I'm taking only one direction to consideration. Whoever is observing it. That means this will become for me V plus of your Vs. Avana? So what is asking for us? Actual frequency. And N kavala. N dash ente ichadu manaku 1800. That is equals to N into velocity of sound is 340. Velocity of source is how much better? What is the velocity of the source he has given for me? Both are moving away with 20 meter per second. So this is your minus 20 divided by your 340 plus of your 20. See how much I'm getting the value of your here.
0.8.
0.8.
0.8.
Option
1800 by 0.8, sir.
ఎంత వస్తుంది మొత్తం?
Sir, something in 2000 is coming, sir.
So 2025, sir.
అంటే నియర్ బై ఆన్సర్ ఏది ఉంది మరి
2020, sir.
what is the nearby answer I can write for that one
1947.
19 అంతే కదా
Sir,
ఇప్పుడు
it's coming 2025, sir. So we should write the highest only, sir.
2025 అంటే నియర్ బై అంటే 1947 కదా ఏమైనా కన్వర్షన్స్ ఉన్నాయా చూసుకోండి మూవింగ్ బోత్ ఆఫ్ దెమ్ ఆర్ వెలాసిటీ దట్ ఈస్ ఆల్సో ఇన్ మీటర్స్ కరెక్ట్ ఇది ఎంత వస్తుంది దిస్ ఈస్ 1800 is equals to this is 340 minus 320 is how much so is equals to ఇది into కదా this one is into ఇది ఎంత వస్తుంది 320 divided by 360 అంతేనా అంతేనా
Yes, sir.
so 32 divided by 36 how much I'm getting beta
8/9.
okay, this one is 8/9 that means it is 1800 into 9 divided by your 8 that is equals to your yeah అంతేనా so 18 nines is how much
16,200.
16,200 divided by your 8 then
Yes, sir.
so that is coming out for me how much n is equals to 2025 hertz isn't it so 2025 hertz and nearby answer for me I can write is nothing but 1947 okay now sure any question may try cheyandi sir in given circuit find the value of resistance capital R so that bulb operates at the rated power of 500 watt and this is the given circuit for us we are having a bulb here right now this is your bulb this bulb is connected to a resistance here right now that is nothing but of your capital R this one is of your 500 watt comma 100 volt okay and this is connected to an external source of your battery positive terminal negative terminal somewhat like this and here it is your 200 volt this is your bulb can anyone try it better direct question again I'll give the options for this one so first one is nothing but 200 ohms second one is nothing but equal to your 30 ohms third one is your 40 ohms and fourth one is your 50 ohms so the first one is your 20 ohms try చేయండి the given circuit find the value of the resistance capital R so that the bulb operates at the rated power of your 500 watt so for the bulb you have got your 500 watt and your 100 volt this one is your 500 watt comma 100 volt for the bulb resistance R is connected in series and connected to a battery of your 200 volt First calculate the resistance of the bulb beta. How do you calculate the resistance power of the bulb?
So 20 volts.
Yeah, P is equals to V square by your R gada. Resistance of the bulb I'm taking it like say small r. So small r is equals to your V square. V and the manaku. Potential is 100 into your 100 divided by your 500. And then E2 zeros will get cancelled. So this will be equal to how much for me? And then
20 ohms.
20 ohms. So we got the resistance of the bulb is equals to 20 ohms. Now can I say that what is the current flowing through this bulb beta? That is your I. I is equals to your V by your R. Isn't it? I is equals to what for me? V by R. V is not given. Can I write in terms of power beta? Power is equals to V into I. So I is equals to power by your voltage. Can I write? Power is 500. Voltage is given how much for me? 100. Then the amount of current is been flowing in this one. 5 amperes of the current is been flowing. Now from this one I can calculate the value of R. R is equals to how much beta? V by your I. V value is given how much for me? 100 divided by this one is 5. So resistance of this one is also how much I'm getting? 20 ohms. Because in series combination, current in this will be the same. So in the current and the in the current series combination. So I can apply here V is equals to I into R. What is potential applied right now for that one beta? Whatever the potential is been in associated with this one, isn't it? దీనికి bulb లో ఎంత అయితే potential ఉంటుందో the same amount of the current will be passing through the resistor part deflection. So R is equals to your V by I. Clear? Is that clear?
Yes, sir.
No doubt ఉందో చూసుకోండి ఒకసారి.
No, sir.
క్లియర్ అందరికి?
Yes, sir.
మన రాసిన దాంట్లో ఎగ్జామ్ క్వశ్చన్స్ అన్ని ఆల్మోస్ట్ చిన్న చిన్న క్వశ్చన్సే ఉన్నాయి. ఈవెన్ రేపు రాసే నీట్ పేపర్ కూడా అట్లే ఉంటుంది బేసికల్ గా. ఈవెన్ ఆల్ ది స్టూడెంట్స్ హు ఆర్ రైట్ నౌ రైటింగ్ ద నీట్ ఇన్ 2022 September 12th ki exactly at 5 or 5:10 I'll be doing the live discussion of the complete paper as soon as the paper will be completed. The 2 to 5 exam ఉంటుంది. The moment I get the paper, maybe in 5 minutes or 2-3 minutes, we'll be getting the paper out. So as soon as we get it, we'll be lively discussing that paper on the Zoom ID basically. So I'm giving my Zoom ID. You can see you can join there 9391326657 and the password is for that one 9391. Will be exactly on September 12th, exactly somewhere around 5 p.m. or maybe or 5:10 p.m. I'll be lively discussing the complete paper of the NEET as soon as the paper comes out on the market basically.
Yeah.
By BCPL you can join out better. That will be a sort me kuda chusukunnatlu untadi. Ayipone topics at least first year topics la unnai questions. Second year la current electricity manam wave optics ayipindi kada. Have we completed wave optics? I think we have done complete wave optics kada. Polarization 7 chesam kada.
Yes, sir. Yes, sir.
Okay. Next year topic start చేద్దాం. So if you get the papers of the previous SJ mains and NEET part deflections better, you please try to practice that questions once. This question right on the lesson. In the adjoining circuit, the battery E1 has an EMF of 12 volt and zero internal resistance. While the battery capital E has an EMF of 2 volt. Okay. So if the galvanometer capital G reads 0, galvanometer is an instrument which measures the current beta, and the current through that is becoming for me 0, then the value of resistance X in ohm is, I'll give the option. First option is 10, second option is 100, third option is 500, and fourth option is 200. This is a given circuit. This is a resistance right now, and here somewhere there is a galvanometer, and to this one there is a battery of positive negative terminal, and here also there is one positive and negative terminal, and this is connected somewhere like this. This is your battery of EMF E. This one is, say for example, of E1. And middle there is one resistance right now. This is your X ohms. So this is a terminal A, this is a terminal B, this is a terminal C, this is a terminal D. The resistance of this one is 500 ohms. This is X ohms E1. Come on, try to do it. In the adjoining circuit, the battery E1 has EMF of 12 volt and zero internal resistance. Well, the battery capital E has an EMF of 2 volts. If the galvanometer G reads this 0, then the value of the resistance X in the ohms will be equal to how much? So which current will be dominating, beta? Current which is coming from the E1. E1 దగ్గర ఎంత ఉంది current? మనకు తెలియదు. So I can calculate that current I. I is equals to your total EMF divided by total resistance. Then EMF ఎంత ఉంది మన దగ్గర? E. Isn't it? So I can write that current value of this value will be equal to EMF, that is nothing but of your E1 divided by the resistance 500 plus of your X. Indukani there is no current in the galvanometer. And this is directly connected by a short circuit right now. So whatever the EMF, whatever the current is being flowing, it will start from this battery and will not go in this one because this is a directly connecting wire. And this is in parallel to this one, isn't it? Whatever is the potential at your X ohms, that will be equal to your E. So that will be equal to how much, beta? E is equals to your I into your R. R is nothing but your X ohms. Ante kada? E X ohms ki battery parallel undi. So whatever the potential is there, ikkada ee renditi madhyalo potential enta untundante E అని అర్థం. So E is equals to how much for me? I into your X. I into your X part deflection. So it is nothing but if your E, This one is nothing but E1 divided by 500 plus of your x into your x. Then E value ente ichadana. E value is given how much for me? 2 ohms. That is equals to E1 is given how much for me? 12 divided by 500 plus x into your x. Tesara? X value ఎంత వస్తుంది చూడండి. ఎంత వచ్చింది? See, I directly took this one because B and C అంటే ఇక్కడ కూడా B and C, there is no current in that one కాబట్టి అంటే దీనికి ఇది parallel combination. I'm directly applying Ohm's law. V is equals to I into R. ఈ V వచ్చేసి capital E, ఈ I వచ్చేసి ఈ current formula. I value this one into the resistance. R value is nothing but equal to your X. అంతే. How much I'm getting the X value?
Hundred, sir. 100 ohms. Yes, sir. 100.
100 ohms, that's it. X is equals to 100 ohms. Good question. Clear?
Yes.
Very soon I'll be starting the next chapter. Better, I'll let you know which chapter will be starting. Morning actually now got physical classes start in, so I will be a little bit problem in the morning hours. Afternoon hours maybe within 2 to 5 we'll try to arrange your classes. So in that mean period I will try to start. Okay, well this weekend gonna exam రాయాలనుకుంటే one more time you write and complete your examination this time. Complete the waves and as well as of your what do you call that, current electricity. Okay, maybe starting a new chapter for you this week or maybe tomorrow most probably. So for this week, if you are writing the examinations, you get mentally prepared that you need to revise your complete waves sound chapter, complete sound chapter and complete wave optics. Wave optics would అయిపోయింది కదా మంది అయిందా? YDSC, polarization, diffraction
Yes, sir.
చేశాం కదా. Current electricity, 3 chapters you try to write as a cumulative one test. So 1 week time ఉంది, రోజు రివైజ్ చేయండి, PYQs జాగ్రత్తగా చేయండి and try to see that you scored in the good box. Okay na? All of them will be having equal weightage beta. For the main students, if it is for your 30 questions, it will be 10 from each of this one, and for the IPC students, if you are writing for exam for 50 marks, there will be again equal sharing of the marks for the all the 3 chapters. Wave optics, waves means sound beta, complete sound, Doppler effect, beats, organ pipes, that all, and complete current electricity including the potentiometer వరకు మొత్తం. పొటెన్షియోమీటర్ నోట్స్ పంపించాను నేను మీకు, పంపించానా లేదా?
So the PDF you sent, sir, like what you said in the class.
I have sent it the PDF. Okay, I don't know, I didn't remember it anyhow. Okay, chalo beta. Okay, if you are not able to understand anything in the class, in the live only you can ask me beta. Don't try to sit mum in the class. నప్పటికీ ఒకటికి 40 సార్లు అడుగుతూ ఉంటాను, అర్థం అవుతుందా లేదా అనేది. మీరు ఓపెన్ అప్ అయ్యి అడగకపోతే మాత్రం ఇంకా మార్నింగ్ పూట నిద్ర మబ్బులో ఉంటే నేను ఏం చేయలేను దానికి, isn't it? So don't make sure that you carry on your doubts for the next sessions. If you are while doing the lecture, if you are having any problem in that one, please let me know. So this concept is not clear for us, you try to explain it once again, but I'm here to explain you the concepts here. అవునా కదా? మీరు నాతో చెప్పకపోతే I can not understand what exactly you are able to follow up or not. So from next chapter, whichever you are starting, make sure that make your fundas very clear. And if you're not able to in the class, you can lively ask me in the class. I'll help you out in that one. Okay. Sure.